In this video, I pulled problems from IXL AA1 to take a look at. So instead of doing the factor tree, if that's not really your method, if that's doing too much with the work, you could go about it a different way. And this is how I'm going to show you how to do it in this video. So first off, we're looking at our 6 and our 8. So we want to find what number can we divide evenly into 6 and also into 8. So think about like 6 divided by what, 8 divided by what. So the highest thing that can both be divided into 6 and 8 is going to be a 2. So 2 is our greatest common factor for a number. And then the second thing we're looking at is our variable with our exponent. When you go to do this with the exponents, you're looking for that variable that has the smallest number of exponents. That's what they're going to have in common. Since both of them are p to the third is going to be your GCF. So they both have 3 p's in common. For the second problem, I kind of stepped it up a little bit. So this is something that you may see after you get one ribbon. And we are looking at a couple things. So first, we're going to look at our coefficients. We have a 2, an 18, and a 22. So again, you could do the factor tree if you wanted, or you want to think about what number can you divide into 2, 18, and 22 evenly, the same exact number. Well, because we have a 2, an 18, and a 22, 2 is going to be the GCF because we can take 2 divided by 2, 18 divided by 2, 22 divided by 2. So now we're looking at our variables. So let's start with the v's. You have v to the 7th, v to the 8th, v to the 7th. So when you have multiple, we have variables with multiple exponents, you want to look to see which exponent is the smallest. So since v to the 7th is the smallest, that's going to be the v, that's the greatest common factor. So remember, they all have to have this in common. So if 2 of them have 7 v's, one of them has 8, they all at least have 7 v's. So we'll have v to the 7th. Now we're going to take a look at our w's. You have a w squared, and a w. Again, you're looking for the exponent that's the smallest, which would just be a single w. So the GCF would be 2 v to the 7th w. Again, you could do a factor tree for all of this if you'd like, or just look to see what they have in common. In this example, you will see that they're throwing in addition signs. Do not let that throw you off. You're still doing the same process. So I would just kind of ignore them. So you got an f to the third, you got a 9f, and you have a 12. So first thing, I would look at your coefficients, your numbers. So we have a 1, that's the number in front of f to the third. You have a 9, you have a 12. So we want a number that you can divide evenly into all 3 of those. Well, in this case, this is just going to be the number 1. Because you can't divide, you can divide 9 by 3 and 12 by 3, but you can't divide 1 by 3 evenly. So our number is going to be a 1. And then we're looking at our variables. So we have an f to the third, we have an f, and then notice that that 12 has no f. So because they all don't have an f, our answer is just going to be the number 1. 1 is the greatest common factor of those 3 pieces. So they have to have something in common to be the GCF. So since that 12 has no f, f is not part of the answer. For the last example, same type of thing as the previous one. We got a plus sign in there, but we're going to ignore that. So let's focus on our numbers. We have 11 and we have 22. So we want to find what is the greatest common factor, what's the largest number that we can divide into 11, also divide into 22 evenly. So that is going to end up being the number 11. So we can divide 11 by 11 and 22 by 11. Now we're looking at our h's. We have h to the 10th and h to the 8th. We are looking for the exponent that is the smallest which would end up being h to the 8th. It's a weird looking h, sorry. It's an h. So we'll end up with 11 h to the 8th. So we're looking for what number that they can be divided by evenly. And then we're looking for the letter, the variable, that has the smallest exponent. So hopefully this has helped with your IXL AA1.